So today's going to look very similar to what we did yesterday, but it's actually very different. Yesterday was more with length. Sorry, my cold is catching up with me. Today is more area, okay? So it's going to look similar in terms of the formula that you use, but it actually is at the same time very different. Don't use the same formula because the same formula won't work. So we are going to start by talking about area of just a circle in general. Anyone know that formula for me? Area of a circle is what? Pi r squared. Pi times the radius squared, okay? So if I want you to find the area of this first circle, you are given, is that a radius or a diameter? That's a diameter. So how do you turn a diameter into a radius? Cut it in half. So this would be 5, okay? So if I want the area of this circle, it would be pi times the radius squared, which is actually what? 25 pi. And how do you label area? Inches squared. Okay, so 25 pi square inches would be the area of that first circle. What about the second circle? 36. Right, 36 pi. Pi times the radius squared. They gave you a radius in this one. So your area is 36 pi square centimeters. Okay, so you do need to know how to find the area of a circle, but the only reason we are covering that is just as a refresher. You know how to do that. The new part is now you're going to be able to find the area of a sector of a circle. And here's how you do that, okay? If we call this sector AOB, okay, if they ever are naming a sector for you with 3 letters, the O, the middle letter, will always be the center of the circle, okay? You'll see that on this next one. So if I want the area of that sector, think about it as, it's like a piece of pie, right? It's a fraction of the whole pie. It's a fraction of the whole thing. So what we do is we take a fraction of the area of the circle, right? So the measure of the arc, or the way we write it on the sheet, is the measure of arc AB over 360 times pi r squared. Okay, so take the fraction of the area. So what we're going to do is use that formula to find the area of this sector. Okay, so using the formula, what's going to go on top of that fraction? What is the measure of your arc? 72. So we're going to say 72 over 360, like the formula says, times what? Pi r squared. So pi times 20 squared. Okay. Now again, like I said before, when we plug this in, we're not plugging the pi in. You're plugging in 72 divided by 360 times 400, or times 20 squared, okay? When you plug that in, you get 80, God bless you, and then you can attach your pi, and then label your units square centimeters. Okay, so very similar to yesterday's formula, but now you're doing area instead of circumference with it. Okay, arc length, you use circumference. Area of a sector, you use area of the circle. Questions on that? Okay, this is the one that can be a little bit trickier, just because there's more components to it. You know how to do all the pieces now. You just got to put the pieces together. So, a segment of a circle. Notice the difference here. Okay, you have a sector of a circle and a segment of a circle, and they're easy to mix up those words, but they're very different, okay? You use a sector when you're finding a segment. So if you look at this picture, if we take the area of a sector, in this case, my sector is here, right? And we take away the little triangle that is formed. So take this away from it. What we're left with is this little piece, which is called a segment of a circle, okay? Not just the line, it's not the segment, the line, it's the whole shaded part is your segment, okay? So we're gonna do that, and I'm gonna show you two different examples. The first one, if it's a right triangle, remember in a right triangle, your base and height are the two legs, so that makes it a little easier to solve. Or if it's not a right triangle, you're gonna have to try to find the area of this triangle. Now there's ways around that. There's a simple way and there's a much more complex way. I'm gonna show you the simple way because I feel like everyone should use the simple way, but I'll tell you about the other one and it's up to you if you wanna use the other one. All right, so let's think about this. If we're trying to find the area of a segment, we're gonna do sector minus triangle, and it will equal the segment. Okay, so how do I find the area of the sector? The sector being this whole thing. What's your formula for area of a sector? Right, oops, arc over 360 times pi r squared, right, is gonna give you the area of the sector. So your arc is how many degrees? Someone said it over here. It's 90, right. This being 90 makes this arc 90. So 90 over 360. What is r? 10. So you're going times pi times 10 squared. Okay, so that's your sector. We can simplify that in just a minute. We're gonna subtract the triangle. Now, if you look at your triangle, the triangle is this. What, in triangle form, if we do 1/2 times the base times the height, what are your base and your height? 10, right? If this is a radius here, the radius here has to be the same. So you're gonna do 1/2 times 10 times 10. Okay, so this is your triangle. From there, it's just simplify. And these ones, because there's a pi in the one and no pi in the other, you don't have to leave it in terms of pi, you can just plug it in. But if you plug this into your calculator, like this whole thing in one shot, you have to do parentheses here and parentheses here. Otherwise, it's gonna do weird math on you, okay? What I usually do is this. I usually take this and simplify it. So 90 divided by 360 times pi times 10 squared comes out to 25 pi, okay? And then subtract 1/2 times 10 is 50. And now that you can just plug into your calculator. 25 pi minus 50, and you get that your area is approximately 28.5 square inches. Does that make sense? So this is the area of your segment. Questions on that?
And then, so on the first one where you got 25 pi, you're still only multiplying?
I'm doing this.
Yes.
Yes. Yep. I mean, you could at this point plug that whole thing in. You could go 90 divided by 360 times pi times 100, and you would get a decimal here, which is fine. You could do that if you want. Okay. Now, what I'm going to show you for this one, this will work on any setup. So you could have done what I'm going to show you right now on the last one. You just can't do what you did on the last one on any, because you won't have a base and a height for this triangle right now. So here's what I want you to think. If we're trying to find the area of the sector, the segment, we have to do sector minus triangle equals segment. Okay? What is the area of the sector? So you need to go arc over 360 times pi r squared. Is that what it came out to? Yes, it does come out to 12 pi. So you're doing, the arc is how many degrees? 120 over 360 times pi Your radius is 6 squared. So when you plug that in, you get 12 pi. Okay? Okay, now here's the trickier, it's not trickier, this is easier, I think. This triangle, if you think about what you know about it, you could turn it into, oh goodness, you could go like this and call this 60 degrees and do the whole 30, 60, 90 and find the base and the height that way. I think it's way more work. If I were you, I would think of it this way. I know this angle is 120. Now what type of triangle do you see? It's SAS, okay? So all you have to do here is your formula, 1/2 BC sine A, right? So I'm gonna go minus 1/2 times B times C times the sine of 120. Okay, so if you just remember that it's an SAS triangle, and think back to this one, so was this, right? 10, 90, and 10. So you could do that on that one too. I just think it's easier to do 1/2 base times height for that one, but totally up to you. If you want to do 1/2 BC sine A on every single one of these, you can, okay? So this is going to be 1/2 times 6 times 6 times sine 120 comes out to 15.588. And then just plug that into your calculator. You get the area of this segment is about 22.1 square centimeters.
So do you just always leave pi, like you always just put in pi towards the end?
I do. I mean, you are totally welcome right here. If you plug into your calculator, 120 divided by 360 times pi times 6 squared versus if you plug in 12 pi. Either one of them, you get 37.69. So you could right here just call this 37.699 and then subtract that. That's totally fine. It's just I'm so in the habit of leaving things in terms of pi that I always simplify it in terms of pi, but you don't have to. Okay? Any questions on that? That's the whole lesson. Pretty short. Yeah.
And which method works for every single circle?
The 1/2 BC sine A. If you treat every triangle like an SAS triangle, you'll always have that information. Because even if it doesn't look like an SAS, you guys, think about it this way. What if they gave me this setup? Okay, they give me a circle. Let me find my circle here. And I have they want me to find this, and they tell me this is 72 and this is 5. Okay? Well, right now it doesn't look like an SAS triangle, but we always know that a radius is equal to a radius, right? So even if we only know this, we actually know that this one's 5 as well. So your two sides here for the SAS will always be the same number. Okay? And then your angle here, so 1/2 times 5 times 5 times the sine of 72. Okay? Questions on that? Yeah.
You go, hold it.
You're welcome.